Julie had a very thought day and went to the roof of her 300 tall building to have some peaceful moments. Drinking a bottle of water on the top of the building was the best at that moment. After finishing the water, a very strong wind started to throw upward a plastic water bottle with an estimated velocity of 100 meters per second.
The first thing we need to do is write the position equation for the plastic water bottle. So we have these values. The initial velocity is 100 meters per second, the height of the building is 300 meters, and the acceleration, that is the gravity, minus 9.81 meters per second to the square. We need to use the formula S times T is equal to the height of the building plus the initial velocity by time plus acceleration by time to the square over 2. We only need to substitute the value, so it is 300 plus 100 by time plus minus 9.81 by time to the square over 2. Then we solve it, and the final equation is minus 4.9 t to the square plus 100 by t plus 300.
In the subsection B, we need to find the equation of the velocity for the plastic water bottle using the derived definition with limits. The formula that we have is the limit when h approaches 0. Is f times x plus h minus the function of x over h. In here we substitute all the values and we have to solve the binomial to the square, and we have this. Then we multiply the 100 times the t plus the h, and we have this. Then we need to multiply the sign by all this function, and we have all this. Then in here we have to simplify the similar values, and the result of this operation is this one. Then in here we use the common factor, and we separate the h, and we simplify h over h, but the minus sign is still here. Then in here we substitute the value h by 0 because it's the limit, and then we have this answer, that is the equation of the velocity for the plastic bottle is this one.
In subsection C, we have to calculate the acceleration equation from the plastic water bottle. So we have this formula, and we have to substitute with the values that we got in the formula of subsection B. So we got this with the substitution of the values, and then we solved the equation, and we got like a resultant like minus 9.8 h over h. So we simplify this, and we have like minus 9.8 meters per second squared, like as a resultant.
Now we need to explain the form of the obtained equation. So the first derivative is the displacement, that is this one. The equation is a parabola, and the acceleration is this one.
In the subsection E, we have to calculate the height of the bottle after 2 seconds. This is the formula we have to use, and we have to substitute the values and do the necessary operation to solve this equation, and this is our final result, and this represents the height of the bottle after 2 seconds. Well, this is a flow chart. The first thing you have to do is read and analyze the problem. Then you have to assign the quantities of velocity, acceleration, distance, and speed. Then you have to search for a formula that has the values you already have, and if you need to, and the variable you need to find. Then we have a condition. If you have to isolate the formula, yes or no. If you have to isolate, you have to do the necessary operation to isolate your variable, and then you have to substitute the values and then solve. If you don't have to isolate, you just have to substitute the values and solve.
So we can conclude that instantaneous velocity, like any limits, is defined at an instant of time. As the change in time approaches 0, the rate of change changes in a point. So the limit of the average velocity when the change in time approaches 0 is equal to the change of position over time.